Okay, we will solve these equations. This is an example of a system of linear equations. We will solve this using Gauss elimination with row pivoting. So each equation will becomes a row and each variable becomes a column. So we have to place also an additional column for the right hand side for our constants. Okay, so this is the augmented matrix. So we will write this way. x1, x2, x3, x4, and for our constants, we have b. So next we will write the horizontal elements. So we have here 6, negative 2, 2, 4, 16. Then for the second row, we have 12, negative 8, 6, 10, 26. Then 3, negative 13, 9, 3, negative 19. Then we have negative 6, 4, 1, negative 18, and negative 34. So I have this augmented matrix. Okay, for the first step, we will use forward elimination. We will make the system reduce to upper triangular form. And next, we will use backward substitution. To do this, we are going to select our pivot element or our pivot coefficient in each row. Make it sure that our pivot element is not equal to 0 because it will lead to division by 0. So there might be a problem if your pivot element is close to or equal to 0. So you are going to switch the rows so that the largest element is the pivot element. So you are going to switch the rows having a largest element. Okay? Okay, I have to copy the augmented matrix because I need this in our next step. Okay, I have to copy paste it here. Okay, for the first row, our horizontal elements are, we have 6, negative 2, positive 2, 4, and we have a constant of 16. The pivot element here is equal to 6, and our target or objective is to make the values or to make the element of this column equal to 0, and the only row not being changed is the row containing the pivot element of 6. For the values or for the element of row 2, row 3, and row 4, we have to replace these values by subtracting the elements of row 2, row 3, and row 4 to the elements of the first row multiplied by a multiplier. Okay, I will write here a pivot because the first row contains the pivot element which is equal to 6, and for my multiplier as m, for the first subscript, it designates the number of the row in which the elements lies, and for the second subscript designates the column in which also the element lies. So when I have here 2, 1, so that is equal to 12 divided by 6. So 12 divided by 6, that is equal to 2. Then for my multiplier of row 3, I have here 3 to 1, that is equal to 3 divided by 6, that is equal to 1/2. Then for the fourth row, we have 4 to 1, that is equal to negative 6 divided by 6, that is equal to negative 1. Okay, I have to erase this one, and I have to replace it by a whole number. So here, this is equal to 2, then this is equal to 0.5, then we have negative 1. Okay, I have to align the multiplier. Okay, these are our multipliers to eliminate x1 in our equation. Okay, so again, we have to copy this format, x4 and b. Then we have to copy the elements of the first row that contains the pivot element of 6. Okay, we have 6, negative 2, 2, 4, and 16. Then we are going to change the values of row 2, row 3, and row 4. Okay, so we have now here okay, so for the second row, okay, for the first element, which is 12, so we have 12 minus 2 times 6, that is equal to 0. Then we have negative 8 minus 2 times negative 2, so we have negative 4. Okay, then we have 6. Okay, 6 minus 2 times 4. Okay, we have positive 2. Then for 10 minus 2 times 4, okay, we have positive 2. And for 26 minus 2 times 16 equal to negative 6. For the third row, okay, we have to change the elements for the third row. Okay, we have 3 minus 0.5 times 6, that is equal to 0. Then negative 13 minus 0.5 times negative 2, that is equal to negative 12. Then for 9 minus 0.5 times 2, that is equal to 8. Then 3 minus 0.5 times 4, that is equal to 1. Then negative 19 minus 0.5 times 16, so equal to negative 27. Okay, so for the fourth row, we have negative 6 minus negative 1 times 6, that is equal to 0. Then 4 minus negative 1 times negative 2, that is equal to 2. Then you have 1 minus negative 1 times 2, that is equal to 3. Then negative 18 minus negative 1 times 4, that is equal to negative 14. Okay, so we have negative 34 minus negative 1 times 16, that is equal to negative 18. So these are our new elements for row 2, row 3, and row 4. Okay, so for the second pivot, we have here for our second row, and our pivot is equal to negative 4. Okay, so I have to write it here. Then we have to find or to compute the multiplier for our pivot elements. So we have here now m, that is row 2, no, okay, that is 3, row 3, column 2. Okay, then for our row 4, the multiplier for our row 4, that is equal to row 4, column 2. Okay, so okay, we have negative 12. Okay, we have negative 12 divided by negative 4, so we have positive 3. And we have here 2 divided by negative 4, that is equal to negative 1/2. So I have to erase this one. Okay, this is 3 and this is negative 0.5. Okay, we will follow again the first step. So we just copy again the format. We have here x1, x2, x3, x4. We have here our constant as b. Then we have to copy the values of row 1 and also for row 2, which contains our pivot element. Then we have to change again the values of row 3 and row 4. This will eliminate x2. Okay. Okay, we have here that is equal to 0. Then for the second element of the third row, that is negative 12 minus 3 times negative 4. So that is equal to 0. Then we have here 8 minus 3 times 2. Okay, that is equal to 2, positive 2. Then we have here 1 minus 3 times 2. Okay, that is equal to negative 5. Then negative 27. Okay, this is negative 27. We have minus 3 times negative 6. Okay, that is equal to negative 9. Okay, for the fourth row, we have, okay, we also have here 0. Okay, we have 2 minus negative 5 times 12. Okay, that is equal to, that is 2 minus 0.5 times negative 4. So that is equal to 0. Then we have 3 minus 0.5 times 2. That is equal to 4. Then we have here negative 14 minus 0.5 times 2. Okay, that is negative 13. Then, okay, we have here negative 18 minus 0.5, 8 times negative 6. Okay, that is negative 21. So again, this is our values for our row 4. And this will eliminate x2. Okay, for our third pivot, okay, this will be our third pivot. So this will eliminate x3. Okay, so here for our multiplier, we have column, okay, we have row 4, column 3. So we have here, this is our pivot, and our multiplier is 4 divided by 2, and that is equal to positive 2. Okay, again, we will follow the previous steps. So copy again the format x2, x3, x4, then for our constants p. Then copy the first row for our horizontal elements. Okay, then for the second row, we have 4, 2, 2, -6. Okay, then for the third row, we have 0, 0, 2, -5, and -9. We have to copy also the horizontal elements for the third row because it contains our pivot, which is equal to 2. We have to change again the elements of row 4. Okay, so we have already this format. So I have to change this to 2. Okay. So we have here 0, 0. Then for our third element for fourth row, we have 4. Okay, 4 minus 2 times 2, that is equal to 0. Then we have -13 minus 2 times -5. Okay, that is equal to -3. Then we have -21 minus 2 times -9. So that is equal to, okay, that is equal to -3. And now our linear equation system is reduced in an upper triangular form or an upper triangular matrix. As you can see, the values below the diagonal elements are equal to 0. So we can solve now the system using backward substitution method, starting from the last variable, so we can compute the value of x4. So we have here -3, x4 is equal to -3. So x4 is equal to -3 divided by -3. So that is equal to 1. Okay, this result can be back substituted into the second to the last equation. So we have 2x3 minus 5x4 is equal to -9. So we have to substitute the value of x4 to this equation. So we have 2x3 minus 5 times 1 equal to -9. So we have to transpose -5 to the right. So this will be equal to 2x3 is equal to -9 plus 5. So x3 is equal to, okay, -9 plus 5, that is -4 divided by 2. So the answer is equal to -2. So x3 is equal to -2. Okay, then we will substitute again the value of x1 and x3 to the second equations, which is equal to -4 x2 plus 2 x3 plus 2 x4 is equal to -6. So we have 4x2 plus 2. Okay, we have x3, we have -2 plus 2, x4 we have 1 equal to 6. So we have -4x2 Okay, we have negative 4 plus 2 is equal to negative 6. We have to transpose negative 4 and positive 2 to the right side. So we have 4x2 is equal to negative 6. So we have positive 4 minus 2. So we have negative 4x2 is equal to negative 6 plus 2, that is negative 2, minus 2, that is negative 4. So x2 is equal to negative 4 divided negative 4, that is equal to positive 1. Okay. For our x1, so for our first equation, we have 6. Okay, we have 6x1 minus 2x2 plus 2x3 plus 4 x4 is equal to 16. So we have to substitute again the value of x4, x3, and x2 to the equation. So we have 6x1 minus 2 times 1 plus 2, x3 is negative 2 plus 4, x4 is equal to positive 1, equal to 16. So we have 6x1 minus 2 minus 4 plus 4 is equal to 16. So negative 4 plus 4, that is equal to 0. So we only have 6x1 is equal to 6. Then transpose negative 2 to the right side. So this will become positive 2. So we have x1 is equal to 16 plus 2, we have 18. So x1 is equal to 18 divided by 6. This is equal to 3. Therefore, our answers for our variable x1 is equal to 3, x2 is equal to 1, x3 is equal to negative 2, and x4 is equal to 1. So you have to box your final answers. Okay, so I hope you understand. Thank you for your time, and God bless.